Hi students, today we are going to see the topic about eddy current testing. Myself Sathish, Assistant Professor Mechanical Engineering Department at Akshay College of Engineering Technology. Eddy current testing. Electrical current are generated in a conductive material by an induced alternating magnetic field. The electrical current are called eddy current because the flow is circle at and just below the surface of the material. Interruption in the flow of eddy current caused by imperfection, dimensional changes, or changes in the material conductive and permeability properties can be detected with the proper equipment. Eddy current testing can be used on all electrically conducting materials with a reasonably smooth surface. The testing equipment consists of a generator AC powered supply, a test coil, and a recorded equipment, example a galvanometer or an oscilloscope, used for crack detection, material thickness measurement, corrosion detection, sorting material, coating thickness measurement, metal detection, etc. Principle of eddy current testing. As the image shows, when an AC passes through a test coil, a primary magnetic field is set up around the coil. The AC primary field induces the eddy current in the test object held below the test coil. The secondary magnetic field arises due to the eddy current. Mutual inductance. The basics for eddy current inspection. The magnetic field produced by circuit 1 will intersect the wire in circuit 2 and create current flow. The induced current flow in the circuit 2 will have its own magnetic field which will interact with the magnetic field of circuit 1. At some point on the magnetic field consists of a part due to current and a part due to current 2. This field are proportional to the current producing them. The following are the sum of the two parts formula. Principles of eddy current testing. As the image says, changes in the magnetic field during pass of a crack. The strength of the secondary field depends on electrical and magnetic properties, structural integrity, etc. of the test object. If cracks or other inhomogeneities are present, the eddy current and hence the secondary field is affected. As the image shows, the changes in the secondary field will be feedback to the primary coil and affect the primary current. The variation of the primary current can be easily detected by a simple circuit which is zeroed properly beforehand. As the picture shows, the eddy current test works on the basis of the electromagnetic induction. In this method, the eddy current are induced in the test object by bringing it closer on to the alternating current carrying coil as shown in figure. This eddy current are normally parallel to the coil winding. The defects in the test object impedance and the change direction of the eddy current are causes changes in the electromagnetic field. This changes affects the inspection of the specimen, the voltage of the which monitored to determine the presence of defects. Depth of penetration. Eddy current are closed loop of induced current circulating in planes perpendicular to the magnetic field. They normally travel parallel to the coil winding and follow is limited to the area of the inducing magnetic field. Eddy current considered near the surface adjacent to an extension coil and the strength decreases with the distance from the coil as shown in the image. Eddy current density decreases exponentially with depth. The phenomena is known as skin effect. The depth at which eddy current density has decreases to 1 by E or about 37% of the surface density is called the stand depth of penetration. As image shows, the test coil are commonly used in three configurations: surface probe, internal bobbin probe, encircling probe. Result presentation. In this image we can able to see the impedance plane diagram is a very useful way of displaying eddy current data. The strength of the eddy current and the magnet permeability of the testing material cause the eddy current signals on the impedance plane to react in a variety of different ways. Application of eddy current testing: crack detection, material thickness measurement, coating thickness measurement, conductivity measurement for material identification, heat damage detection, cause depth determination, heat treatment monitoring. Surface breaking cracks. Eddy current inspection is an extant method for detecting surface and near surface defects which the probable defects location and orientation is well known. Successful detection requires a knowledge of a portable defects type, position and orientation. Selection of the proper probe. The probe should fit the geometry of the part and the coil must produce eddy current that will disturbed by the flaw. Selection of reasonable probe drive frequency. For surface flaws, the frequency should be as high possible for maximum resolution and high sensitivity. For surface flaw, low frequency are necessary to get the required depth of penetration. Application of encircling probe. Mainly for automatic production control. Round boss pipes, wires and similar items are generally inspected with encircling probe. Discontinuity and dimensional changes can be relevant. In-chute monitoring of wires used on cranes, elevators, towering cables is also be useful application. Application with internal bobbin probes. Primarily for examination of tube in heat exchanger or oil pipes. Become insightly popular due to the wide acceptance of the philosophy of prevent maintenance. This picture shows the eddy current testing of a heat exchanger. Advantage of eddy current testing: sensitivity to small cracks and other defects, detect surface and near surface defects. Inspection gives intermediate result. Equipment is very portable. Methods can be used for much more than flaw detection. Minimum part preparation is required. Test probe does not need to contact the subparts. Inspect complex shapes and size of conductive material. Limitation of eddy current testing: only conductive materials can be inspected. Surface must be accessible to the probe. Skill and trained required is more extensively than other equipment. Surface finish and the roughness may interfere. Reference standards needed for setup. Depth of penetration is limited. Flaws such as determination that lies parallel to the probe's coil winding and probe's scan detections are undetectable. Thanks for listening, students. Thank you.